Hi everyone! For this video, we're going to solve different problems involving trigonometry. Let's start! Number 25. The pointer on a voltmeter is 6 centimeters in length. Find the number of degrees through which the pointer rotates when it moves 2.5 centimeters on the scale. Letter A, 1/2. Letter B, 3/4. Letter C, 5/12. Or letter D, 6/25.
Need to use the formula theta equals to S over R. So, let's just substitute the given 2.5 divided by 6. And we should be able to get 5/12.
Number 26. A sprinkler on a golf green sprays water over the distance of 15 meters and rotates through an angle of 140 degrees. Find the area of the region. Letter A, 264.78 square meters. Letter B, 274.89 square meters. Letter C, 284.90 square meters. Or letter D, 294.01 square meters.
So first, we're gonna write down the solution for area. So we're gonna put A equals 1/2 times R squared times theta. That is our solution. And now we're gonna write down the given in the question. For our degrees, we have 140 degrees. And for our radius or R, we have 15 meters. 15 meters. And now, we're gonna convert our degrees, which is 140 degrees, to radian. So how we're gonna do that? So we're gonna put 140 here times pi over 180. So we're gonna times it. So to get 140, we need to divide it to a number divisible by 140. So a number divisible by 140 is 7, and 7 divided by 140 is 20. So we're gonna cross out 140 and put 7 over here. And the same goes for 180. A number divisible by 180 is 9. 9 divided by 180 is 20 also. So we're gonna cross out 180 and put 9. And that's how we get our radian. 7 pi over 9. And for the final part, to get the final answer, we're gonna use our solution. So, we're gonna put 1/2 times our R, which is 15 meters, squared, times our radian, 7 pi over 9. And if we multiplied all of this, we will get our final answer, and the answer to this question, which is 274.89 meters squared. So, here is our final answer for number 26.
Number 27. A sprinkler on a golf course fairway sprays water over a distance of 70 feet and rotates through an angle of 120 degrees. Find the area of the fairway watered by the sprinkler. Letter A, 5,131 square feet. Letter B, 6,131 square feet. Letter C, 6,132 square feet. Or letter D, 7,131 square feet.
This area is 70 and this area will be 120 degrees. So, we're gonna convert the degrees to a radian. So, 120 degrees times pi over 180 degrees. First, we're gonna cancel this and this 180 degrees. This will be 2 and this will be 3. So for answer for this is 2 pi over 3. So let's move on to area. How to find area? This is the formula of the area. 2 equals to 1/2 times radians squared times theta. So let's distribute our given. 1/2 times 70 squared times 2 pi over 3. So first solve this 70 squared. So the answer is 4,900. So 1/2 times 4,900 times 2 pi over 3. So it will be, the area is 5,131.268, or this will be 5,131 feet.
Number 28. Clock strikes 3:10 p.m. and you were asked by your pre-calculus teacher to identify the cosecant function of the time. Applying trigonometry, find the cosecant theta of the given time. Letter A, 1/2. Letter B, square root of 2 over 2. Letter C, square root over 2. Or letter D, 2. So in this number, we are tasked to get the cosecant of this angle. As you can see, circle unit, and clocks are the same since a clock is a circle. And here we have this angle. And this angle forms a 30 degrees since it is in 3:10 o'clock. But if it is in 3 o'clock, it is 90 degrees, but our given is 3:10 o'clock. So this angle is 30 degrees. So our sine is going to be 30. And sine 30 is equals to square root of 1 over 2, or 1/2. So since we are tasked to get the cosecant, as we all know, cosecant is the opposite of sine. So we're just going to reciprocate this fraction. So 1/2 is going to be 2 over 1. Since we reciprocated this fraction. So 2 over 1 is equals to 2. 2 over 1 is same as 2. So our final answer is 2, which is letter D in our answer sheet. Number 29. An airplane flying an altitude of 6 miles on a flight path that passes directly over an observer. Let theta be the angle of elevation from the observer to the plane. Find the distance from the observer to the plane when theta is equals to 30 degrees. Letter A, 12 miles. Letter B, 6 miles. Letter C, 6.9 miles. Or letter D, 12.9 miles.
In this problem, I am tasked to find the distance from the observer to the plane. So first, we will need to find the given, which is the opposite, which is 6 miles, the distance, which is missing, and the angle of elevation, or theta, is equals to 30 degrees. So in order to find the distance between the observer to the plane, we need to use the formula called SO, or sine equals to opposite over hypotenuse. So just substitute all the given. Sine 30 degrees equals to the opposite, which is 6 miles or 6, the hypotenuse, which is missing. Next, we will multiply both sides by d to cancel out the variable numerator. Cancel. Then we will be left with d sine 30 degrees equals to 6. The next step we're about to do is to divide both sides by sine 30 degrees. cancel, and D is equals to 6 sine 30. So, if we type this in our calculator, we will be able to get the answer, which is 12. So, the distance between the observer to the plane is 12 miles. Then,
Number 30. From number 33, find the distance from the observer to the plane when theta is equals to 90 degrees. Letter A, 12 miles. Letter B, 6 miles. Letter C, 6.9 miles. Or letter D, 12.9 miles.
Assuming that the distance of the airplane flying at an altitude of 6 miles on the flight path that passes directly over the observer. Consider that theta is the angle of elevation from the observer to the plane, and x is the distance from the observer to the plane. From this problem, we will use trigonometric functions to aid us in solving this problem. Sine theta is equals to opposite over hypotenuse. Then we will substitute 6 to opposite, since 6 is opposite and x is hypotenuse. And after that, we will substitute theta to 90 degrees since it is stated in the given situation. And lastly, we will transpose it to give us the final answer. Then, the final answer is 6 miles.
Number 31. From number 33, find the distance from the observer to the plane when theta is equals to 120 degrees. Letter A, 12 miles. Letter B, 6 miles. Letter C, 6.9 miles. Or letter D, 12.9 miles.
Here, we have the figure in number 33, which is the observer and the plane flying in the altitude 6 miles, and the distance, which is x, and the angle or theta. So, in the given number 33, the given is opposite equals 6 miles, theta equals 120 degrees, and x. So, we will use the trigonometric function SO, which is sine equals opposite over hypotenuse. So, we will use this formula, which is sine theta equals opposite over hypotenuse. So, we will substitute all of the given. So, sine theta or 120 degrees equals opposite, which is 6 or 6 miles, over hypotenuse or the distance, which is x. So, for us to get the value of x or distance, we will multiply each side by x. So x sine 120 degrees equals 6 over x. So we will cancel the x on the right side and the x in the denominator. We are left with x sine 120 degrees equals 6. So we're still not done yet. So we will divide sine 120 degrees over sine 120 degrees as well. And also the 6. So we will cancel this, and then we're left with x equals 6 over sine 120 degrees. So we will calculate this by dividing this 6 divided by sine 120 degrees. It is equals to 6.928 or 6.93. Because 8 is a large number, we will round up 2 to 3. So x or the distance is equals to 6.93. That's
Number 32. A Ferris wheel is built such that the height h in feet above the ground of the seat on the wheel at time t in second can be modeled by h times t is equals to 53 plus 50 sine times pi over 10 t minus pi over 2. Find the period of the model in terms of seconds. Letter A, 10 seconds. Letter B, 30 seconds. Letter C, 20 seconds. Or letter D, 15 seconds. So in this number, we are tasked to get the period. And the formula in getting the period is P is equals to 2 pi over b. So we're going to substitute the given in this formula. So we're going to Vp is equals to 2 pi over the b, which is pi over 10. So to solve this, we're just going to multiply it and reciprocate the denominator. So it will going to be 2 pi multiplied by 10 over pi. It became 10 over pi because we reciprocate the denominator. And after that, we're just going to solve it. And the answer will be 2 pi times 10 is equals to 20 pi. And the denominator is pi. So here is the answer, and to simplify it, we're just going to cancel the pi. So that will leave us to the answer 20. So our final answer is 20. Number 33. Find the amplitude of the radius of the Ferris wheel. Letter A, 50 feet. Letter B, 51 feet. Letter C, 52 feet. Or letter D, 53 feet. In number 33, we are tasked to get the amplitude or the radius of the Ferris wheel. And in this number, it is really simple to find the answer since the answer is in the given, which is the 15. So our answer is 50 feet.
Number 34. When turning a piano, a technician strikes a turning fork for the A above middle C and sets up a wave that can be approximated by y is equals to 0.001 sine 880 pi t, where the time is in seconds. Letter A, 1 over 440 seconds. Letter B, 2 over 440 seconds. Letter C, 440 seconds. Or letter D, 880 seconds.
Represent simple harmonic motion where y is the displacement, 0.001 is the amplitude, 880 pi is the angular frequency, and t is the time. The period of the wave denoted by t is given by t equals 2 pi, and where is the angular frequency? Substituting the given angular frequency, which is 880 pi by the given formulas. And 2 pi divided by 880 pi is 1 over 440. And the answer of this question is letter A, 440 seconds.
Number 35. You are standing 45 meters from the base of the Empire State Building. You estimate that the angle of elevation to the top of 86th floor, the observatory, is 82 degrees. The total height of the building is another 123 meters above the 86th floor. What is the approximate height of the building? One of your friends is on the 86th floor. What is the distance between you and your friend? Letter A, 443.2 meters. Letter B, 403.22 meters. Letter C, 363.23 meters. Or letter D, 323.24 meters.
So in this problem, we need to find the distance between you and your friend. So the formula we need to use is ca or cosine theta equals to adjacent over hypotenuse. So next is just substitute all the given. Cosine, the theta which is 82 degrees equals to the adjacent which is 45 over the hypotenuse which is missing or the distance. Next is multiply both sides by d to cancel out the variable of the denominator here. So next we are left with d cosine 82 degrees equals to 45. Next we need to divide both sides by cosine 82 degrees. Next cancel. So we are left with d equals to 45 over cosine 82 degrees. So to find the answer, we just simply need to type it into our scientific calculator, which is cos 45 over cosine 82 degrees. So our answer is 323.338 or 323.34 meters.
Number 36. A guy wire runs from the ground to a cell tower. The wire is attached to the cell tower 150 feet above the ground. The angle formed between the wire and the ground is 43 degrees. How far from the base of the tower is the guy wire anchored to the ground? Letter A, 219.9 feet. Letter B, 204.9 feet. Letter C, 190.9 feet. Or letter D, 160.9 feet.
Beginning this problem is the opposite, which is 150 feet in the
angle is 43 degrees. And the missing in this problem is the distance. So, to find the distance, we need to use the formula or sin theta equals opposite over hypotenuse. So, we need to substitute now the given. Sin 43 degrees over the hypotenuse, which is the 150 feet, and the distance. So after this, we need to multiply both sides by 2. Cancel. So B sin 43 equals to 150. And next, we need to divide it both sides by sin 43. Cancel. So the answer is B equals 150 sin 43. So if we solve this in the scientific calculator, the answer is 219.9.